I'm happy to be here. My name is Henry. I'm from Hamburg in Germany, and I'm partner of WebHook, which is a consultancy and a MSP for Jam stuff and other stuff in Germany. And we created a tool that is surrounding osquery as well as Santa. And that's the talk I'm giving about for today. Combine the power of osquery and Santa with Zentral. So we learned by what Alistair already explained that osquery is very much focused towards security and monitoring. So these are two things I want to briefly scratch, but we have to dive into it. And let's start with security. So if you look into the security market, there's some stuff like security monitoring and alerting, sophisticated threat intelligence, and all those things are glued into products. And if you look at it, you know it's a growing market, and there should be some money involved because there's products popping up. Luckily, there's also open source products. If we look into the market itself, again, there are those acronyms and abbreviations. Alistair loves them. And if you look at this, you can really get a little bit, probably not lost, but it's a lot of different patterns you see here. And what to make with this? What is the right thing, the right strategy I need, especially if we're Mac-focused? What do we need from that here? What is the best thing we have to pick? So if you put all those words into a word cloud, it comes out, it's management, inspection, analysis, and somehow preserving integrity and security. So this is a bit easier. So yeah, that's probably what we want. And so the flip side of that would be monitoring and stability. So we have to see that on this one is the defensive side, the other one is more like the stability, the positive side. So I want to look at both. So back to monitoring. There's reasons why we want to monitor, why we have to monitor, because we have a growing need. So the need is that we need to measure more and more in our IT systems. And the main reason is that there's businesses we are working at, and we need to support the core business and the complete business. And for that, our job in IT is to make it safe, to make it stable. And so with monitoring, we can gather more information about the state of our complete technology environment. There's different strategies in monitoring. But generally, it's used to resolve issues and find vulnerabilities. And of course, if things go bad, you can use monitoring to detect this. And monitoring is a tool to mitigate the risks and also post-mortem investigate during the remediation process. So there's a very popular no monitoring, and this is like this. This is flying without instruments. So it's better to have those roughly described patterns. The manual monitoring would be just SSH into a machine and just like checking log files and looking for patterns, information. We all have done that in the past and probably all do this tomorrow as well. There's the more reactive model of monitoring, which is sort of automated. Let's say you ship the logs to your RSys log server. Many log files come to one server, and you can have some sort of thresholds that notify you. But this is more a reactive model. And there's a more modern proactive way, which is also automated. You collect lots of more data, and you have a process to analyze the data, and of course, in the end, you want to get notified or alerted with the context of what happens, correlations, and all that stuff. Most modern monitoring architectures have a fully searchable database. Yes, that's good to have. And you have certain patterns to search in depth or more roughly. So sometimes you want to know a broader overview, and so granular probes, or you need to have very high resolutions. And with the use of time series events, you can see patterns in how they happened over time. So you have the chronological view. And of course, correlating events and alerting is some stuff that Splunk or so are doing very well, as far as I heard. The open source tools that we heard already by Alistair is the Elk Stack. There's Prometheus from SoundCloud, Graphite Grafana. These are the open source tools that are very popular in monitoring. And on the commercial side, it's Datadog, Splunk, and probably many others. If we come to the visualization, there's from the Elk Stack, Elasticsearch, that's the database, and all the time series metrics are stored in that database. It's a very scalable database, probably not as scalable for the needs of Facebook, let's say, or Google. They do their own stuff, or they have to scale on another level, let's say. But Elasticsearch can grow a lot, and there's expertise by people who know how to do that, who know how to cluster Elasticsearch. So if you use Elasticsearch, at least for a large amount of data, you should be quite safe. But this is just a database, and you want to have some options to discover what's in the database. And for that, there's the Kibana 4 as the web interface, and you can discover, search, and also visualize the data over time. And this is just one example what we do with Kibana. This lower one is just that there's an event on the timeline, and you can make some nice dashboards. Prometheus is another tool that's invented by SoundCloud. There's two engineers who formerly were with Google, and then they went over to SoundCloud. And as far as I know, one is still remaining at SoundCloud, and the other is somewhere else in Berlin working both together still on Prometheus. And the next version will skip that graphical interface and replace it with Grafana, as far as I know. Here we see just the progress of a rollout of Google Chrome. And this is pretty nice because we have the timestamp values. So you can really see when changes in your fleet happen over time. So why should we do all this? Because we want to visually understand the changes. So you can track and measure how long things took. And of course, statistics help to find patterns, and even if you have to report to somebody else who's more like the business side of things, they want to have numbers and figures and success and whatever. So the monitoring part helps us to answer questions on compliance and, of course, to discover also the areas of ad hoc interest. And this pattern is something that we later on find very much glued into osquery, which is quite cool that we have osquery. But there's some challenges. If we want to bring in monitoring to our fleet, we have to, of course, process all the data. We have to find patterns, how to do that, what is our business need. Everybody has a special or different business need. And in case of MacDevOps or Mac-focused people, we have to take responsibility for our Macs. And lots of the monitoring patterns are towards servers. Some patterns are matching, but others are not. So you really have to think about, what can we do with our Mac endpoints? So what are the strategies? So we have to discover some tools. And because we want to have broad-scale information over our fleet, and we want to have in-depth metrics. And this is, let's say, the T-shaped information we are looking after. And the standout information so helps us to find patterns and react on that. So in this case, it's not already this fault detection, but you can also use it in other directions. And there's also in this whole thing that we have to take care about a few things, because mostly the devices are owned by a corporation, but are used by users personally with personal data on it. So you don't have to introduce those tools and break trust with the users. And Alistair just explained that in more detail. What you may not want to gather with osquery from developers, as if they are aware that you store all those information, they may get angry, and then you have a problem. And the responsiveness is also something that is very crucial in doing the modern way of monitoring. And of course, automating stuff and only notifying where needed is important because there's so many information and we don't want to get fatigued by all the alerts, but we still want to have a high velocity of doing things. So the challenges are we have to integrate new tools to our existing ones because we're not starting from zero. We already have workflows. How to integrate those new patterns of monitoring, of reactive monitoring, to our existing stuff we already do. So, and we have to find our specific way per organization, what we need to measure, what we need to log, what we want to monitor. And there's events happening in IT where today we think, oh, everything is safe, and tomorrow there's a new vulnerability popping up, and we have to take actions. So, but when doing this, we don't want to go into Big Brother mode. So this is always important. And how to achieve that. So whatever tool you pick or whatever tool chain you pick, you have to have an adoption process. You have to integrate stuff, you have to learn stuff, how it works in your organization, and customization is, I guess, required there's no out-of-the-box experience, and it works for everybody. So the synergy of tools is with osquery that you can ask the questions to your fleet of devices, especially Linux and macOS. And Alistair explained the SQL syntax that is used. And it's very important that osquery is not hidden. It's not a black binary that you buy from a shelf of a security vendor. So you can really see the source code. You can follow the progress of the tool. And osquery has a very great community. So you can learn from the community how osquery could be used in your use case. Another tool that is very interesting is Google Santa. Google Santa is a binary black and white listing system and an event logging system. Santa can detect with the kernel extension what happens, what binaries are started on your Mac, and because it's just working on OS X or macOS. And it can keep track of binaries. With fingerprint, it can block the execution of a binary. And this is very cool in case of, let's say, malware. You can, if you have the fingerprint, you can just block the execution, and it will not even start. So it can separate between the naughty and the nice. And it works with a kernel extension and a daemon, and both interact in secure ways. Google has built a kernel extension has to be signed by a larger entity. So if you want to compile the source code of Santa, which is open source, then you have to either have that opportunity to compile it and get it signed by Apple, or you use the version that Google is providing for us. Google has two modes: the monitor mode, which is just the one that we mainly use within Zentral, and the lockdown mode, which is more like the only whitelisted apps or whitelisted vendors by the signing certificate are allowed to run, and all the rest is blocked. So this is the default deny strategy. Now, I'm talking about Zentral, and Zentral is our way to coordinate osquery as well as Santa. So we provide the configurations and the query updates for osquery, and we provide the policies for Santa. And in return, as we're a TLS server, we get shipped back the results. And technically, we're like Zentral is an event processing and action framework. So, as I explained that we have existing tools, existing workflows, we know we already have some inventory. Some people use Casper, others use Munki, and so there's those inventory sources, and we deal with many of them. And finally, we try to make Zentral to become a if this then that event processing tool that can react on the metrics that are happening on the endpoint. And osquery and Santa are the tools that enables us that. We don't have a Zentral binary that you have to install next to osquery, next to Santa. We just use the power of those tools and the scalability of those tools. And we're a small company. We're about 14 people, and 4 of them are just repairing Macs and iOS devices. So it's not 10 people engineering. It's just like 2 people doing the engineering work of Zentral currently. And it's open source, so we hope for contribution. That means if I trust on a small company doing a binary, how could they test it? But in case of osquery and Santa, we know Google and Facebook, they have such a large fleet of machines, they can test it well. So we only use those tools and put a higher level of management with Zentral. And we also have dealt with the notification part. So we integrate a lot of integrations, a lot of tools for sending out notifications in different ways. I show that a little bit later. And Zentral is, oops, is it working? Yeah. Zentral is mainly a web service. It's written in Python 3. It works with a Django framework. And as explained, or hopefully I could explain it enough, we're an event aggregator. So we get the events from Santa, we get the events from osquery, we get even events from Munki, and we get events from other inventory tools as well. So how we do that? We try to come up with a common pattern of dealing with APIs, and that's the if this then that thing. We're very extendable. So let's say we support Zendesk in a special way, I show later on. But if you are using Jira, you could do a similar thing with just 30 to 40 lines of Python. And this is an extendable action you could plug into your Zentral instance, or you could also open source and share with the public. And we store our events also in a full text searchable database. That's Elasticsearch. And we're very modular from the complete approach. So all the tools we use could be plugged out and replaced by another. So we use Redis, and we could replace Redis tomorrow by another tool that does the same thing. If that tool is better in whatever case, if that tool scales better, just plug it out, plug the new one in, and it may work. So let's look into the event processing, how we do that. This is a Zentral web interface, and I have to see the laser pointer. Yes, it works. And this is one device. And this device here has an event section, and here we see that osquery, a request, was just happening here, and a Santa event just reported that the JSS, that the Jamf binary was running, and some context, including the signing chain of the Jamf binary. And if I go to a probe, a probe is our mechanism to distribute osqueries and to scope one osquery towards all machines or a group of machines. And a probe could be activated, and it has a filter, and the filter, because a probe could be for osquery or for Santa or for Munki events. So we have to filter on, OK, this is osquery. And then we can have another filter on the payload. The payload means that we get shipped some information with metadata back from osquery. So we are here only interested in the actions when osquery says, oh, I add something, I detected a change, and if it reverts back to the previous state, in this case, with this probe, we're not interested in. And here's the osquery, which we display in the web browser so that you can read SQL a bit better. In fact, this here is a probe that reads the contents of the 1Password plist, and it checks the parameters. So this is a compliance check. You roll out 1Password to all your Macs, and you say, oh, these are the default values we want to start with. And if a user changes that value, osquery can detect that and just report on that. And you know, oh, this user just changed settings in 1Password that are not compliant anymore, and then you can start to act on that. So, and this information could even be displayed in Kibana because we get all the metrics back from osquery, what has changed. And here I can see, of course, Kibana doesn't know about the default values, osquery knows. But I can see, okay, what has changed on this specific machine? And this is quite nice. You just start to use data that is visible in the Kibana and just explore things that you would have not seen by just inspecting a specific machine. Here's a probe for Santa. It looks almost the same because it's the same web interface. It's active. We have a filter, but now the type is a Santa event. And here's a Santa policy. And the policy says, OK, here's a blacklist, a fingerprint, a SHA-256 of a binary. And this binary is not allowed to run. And if the binary is started, Santa will notify Zentral, and Zentral can take actions. In this case, it just tags the machine. And if the machine gets this tag, which happens here, Santa blocks the binary, and it could say malware detected. And now this machine belongs to a group with malware detected, and on that group, we could take further actions. So this is a thing of with the Jamf has those smart groups. This is a similar mechanism, but we could use Santa or osquery or Munki events just to smart group. So tags could be set manually or by alerting. So in terms of Munki, we get all the Munki inventory event. So Munki works the way that it has a local inventory. It's already there. It's on the machine. And with a Munki post run, similar to Cell or others, we just ship the information, we filter that, and we store it in Elasticsearch. And here you can see for a specific machine or specific device what osquery, what Munki has installed in the last 30 days. So it's just a visual representation, but it's nice that you can drill down to specific machines or all machines. That's quite nice. Same here with Watchman. We also have an integration with Watchman. Here you can see all the issues in the last 24 hours that Watchman has detected over, let's say, a larger fleet of machines or devices. And yeah, Watchman itself has a good interface on alerting, so it's just another representation of the same data and enables us to correlate those events within one interface. So modular monitoring. The patterns we try to follow is that we want to be as flexible as possible. And the technologies we integrate with, like osquery and Santa, and also Munki, enables us to do that on certain levels. The scan-based monitoring is if you use the feature of a distributed query, which means you have an interface in Zentral, you insert your query, and you send it out to all machines, or you shard it to 30% of the machines in your fleet, and then you get the results, immediate results. So this for testing osquery, just see what you get in return. So it's like the interactive, the osquery I version, but you distribute it to your complete fleet. Then there's this trigger-based monitoring, which is the osquery packs that run on a scheduled level, and usually they detect, it's all fine, everything's good, and then they detect a change, and so the osquery packs, and then they could alert us. And it's also the complete inventory events that come from Munki, from Watchman, or other sources. The continuous monitoring, I would say, is more the in-depth stuff, and also what Santa is giving us with much more detail. Process, Jamf binary has started in this user context. It has this signing certificate. This is more in-depth information. And osquery file integrity monitoring, of course, I could define certain areas on my system and say, look for patterns just specifically in those paths, which is the very, very powerful way of doing things. And if we gather all the data in Elasticsearch, we can use the discovery, which is happening with Kibana, and just go over time in a historical perspective and find things that are stored in there. So this is the discovery-based monitoring. So how does an event lifecycle look? So we have osquery, Santa, and Munki and on the endpoint. This is the emitter. And we have Zentral, which is more the collector of things. And so those three technologies push events to Zentral. So in one way. And of course, the config changes. If we have a new probe that tells osquery, hey, check this as well. The osquery D asked the Zentral TLS server for the new config. That's going in the other direction, but the events are just shipped towards Zentral. And then if it's in Zentral, it's going into the process or filter. And as said, we can take actions. So we have near real-time information on what's happening. And also, if we want the historical perspective. So this enables some sort of proactive monitoring, as we can look for patterns with osquery or with Santa, or even Munki events. And the alerting is getting very interesting, and I show a little bit more of this. In that case, for the flexible response, we can auto-activate a Santa restrictive policy, a blacklist, if we tag the machine. So event X happens, we don't want to have this happen, and then just activate Santa, and then the Santa policy kicks in and can block a binary. So this is a very, very efficient process, in my opinion. And of course, we can search all the events in a historical way, as I've shown in Kibana. So we're quite flexible as we collect not only issues and alerts, we collect standard events. We have the possibility to use the distributed ad hoc queries. And so this gives us information to act on very quickly, but with context. It's not like alert, something happened. It's something happened on that device with this osquery or with this Santa policy. And we even provide links to your inventory. So if you use, let's say, the Jamf JSS, we directly show you a link where you can click on, and then in the full inventory, you have the information from the device. The tagging system we have gives us a very powerful automation. And so we try to come up with these tags and filtering to enable that collision detection patterns. And then this alerting and notification is also very flexible. So we can build our escalation chains and our response strategies quite in an interesting way with Zentral. The responses on issues could be that we see a trend and we can automate on that. Of course, we can use MDM. In this case, it's the Jamf JSS. And we can change the group membership within Jamf as an action. So, and then we can kick in all the MDM powers that are not involved with osquery, that are not involved with Santa. So this gives another level of power to use MDM as the result. You could switch to Santa lockdown mode, which means everything is blacklisted unless it's signed by a certificate that is whitelisted or specifically whitelisted. And we have the file integrity monitoring that Alistair mentioned. And yes, so this is the stuff that we can use to create our mitigation and remediation processes. The integrations I've mentioned a couple of times. The endpoint security tools are osquery and Santa. Then we have the endpoint management software solutions, which is Munki and the JSS, Jamf Casper Suite. And we have more inventory events and metrics coming from Watchman, or we also support Cell. Anything that has a REST API technically could be connected with. And this is the input. And on the output, of course, we could trigger group changes in the JSS, and then we can act with MDM, or that could be another MDM that has a REST API. There are not so many MDMs with a REST API. There's an open source one. This is very interesting. We want to look into that very soon. And of course, having one notification, sending out an email to this team is a bit limiting. We support GitHub, so we can create GitHub issues. We support Slack. We can do some crazy stuff with Zendesk. I later on show here in the presentation. We can push to iOS devices, create Trello cards, and give Trello cards funky colored labels. We can send out SMS or general webhooks. So the output, the actions we take, can go to nearly many different directions. And then we have the subsystems, which is Elasticsearch as the database, and Kibana. We also use Prometheus and Grafana in our workflow. And we want to build on both of that more in the upcoming future. So how does this work in more detail? The workflow for processing is there's the events from Munki, osquery, and Santa. There's a config or the post flight, and this ships the events towards Zentral, which is here the Django HTTP representation. And there we have the processing part. We have a queue system, a store worker, and the store worker adds some metadata, timestamping and hashing and whatever. And we store that in Elasticsearch and Postgres. So we decide, OK, this is good to have in Elasticsearch, and other metrics are stored as well in Postgres. And then as we have to with the probes, we have the actions. We need to queue again and put that into the process worker, and the process worker then could trigger actions towards Zentral, Slack, and all this, and tag machines. Then we have inventory, which is coming from Munki and Jamf and Watchman. So this is the inventory source. We have a worker again that processes all this scheduling to get information from Watchman or Jamf via the API, the REST API. And of course, we store the diffs in an inventory store. So that's the way how we can see the progress, the rollout of Google Chrome, Firefox, whatever, over time. So, and as an action, we can notify certain inventory, or we can talk back to that. In case of the JSS, I explained that we use that mechanism to just change the group membership of that specific device, and then the group says, OK, we revoke the VPN profile via MDM, and so no VPN access anymore. And then we have the visualization part, which sources from Elasticsearch and also from the inventory store, and this is Kibana and Prometheus. So let's come to some new features. So Zentral is a bit, we started to announce Zentral in public in October last year. So it's about 9 months old. And we started coding around, a year ago. And so now here's some more features. Of course, the devices have to talk to Zentral, so you have to enroll them. We have those sections for Munki, Santa, and osquery. And osquery has we have business units. So I don't go too much into detail to the business units. I did that in a presentation in February in London. And I have to, we have so many features that I have to reduce it a little bit. A business unit practically is just, you can work with only one business unit. We're an MSP, so we have about 120 business units. So we have to decide which business unit we want to enroll that device with osquery or Santa or Munki. And for enrollment on macOS, we built the enrollment package, which is practically the configuration for osquery that says, OK, here's the Zentral server. Here's the cert you need, and here's all the details you need to connect to Zentral, and then all the data we get from osquery or Santa then is associated with this business unit, and we can search only in this business unit, and then we find all the details just for that device in that business unit. As osquery also supports Linux, we also have a script that downloads osquery, installs osquery, and enrolls the Linux server or the Ubuntu server in that case with Zentral. So you can use it also on Ubuntu. So the tagging feature is something that we introduced around February, March, and this is our very powerful way of creating groups or smart groups. And as we have this action, an action also can add a group or add a tag or remove a tag. So I only showed like, Santa detected malware and tagged this machine. Another process could say, I double-checked it, the problem is gone, and remove the tag again. This is the automation. Switch something on and switch something off on condition on the endpoint. This is very, very powerful. And the tags will generally work across business units, but there's certain tags that are only important for one business unit, so you can really restrict the business unit, the tags to a specific business unit, so that you can't apply that tag, the mechanism, the probe that is written specifically for that customer. You can't attach that to other business units. And the tags can be used to set scope for distributed queries. I can say, okay, I just want to send out a distributed query to only the devices that have this tag, and then I get my results. And the same for probes. And with the probes, you would use a filter and say, here's a probe of osquery, but just limit that to devices that have the tag number 19 or number 13 or those patterns. How does it look like? Here's a small demo. Oops, if it works. Yes. So this is the type of a Santa event. I have a blacklist policy, and I dynamically set a tag right now as the action. So here I have the device, which currently has 3 tags. And I start a binary that is blacklisted by Santa. In the background, Santa pushes that information towards Zentral. And if I reload the browser, the machine is, or the device is tagged, malware detected. So it's very, very fast we can act on. We can also search over all the devices we have. This is another demo of how we improved the search. So it wasn't that way in February when I was in London at a conference. There we had search, but not that advanced. Now we have pagination. And here it's like 893 devices. And I have the pagination, so I can look it up that way, but this is a bit boring. So it's good that we can search by serial number, if we get that, or by device name, but there's administrator Mac. We can search by source, so we can draft it down that way. And let's see how fast the search is over roughly 900 machines. It's quite fast. And I can search on tags as well. So this is very nice, as I can just say, okay, this is a tag that is tied to a specific business unit, and this is a tag that just looks for the compliance issues. And it finds me those 2 devices out of 900 that have this specific tag. And this is super fast. And as we have the probes, formerly you had to upload or had to change the probes on the Zentral server and reload a process. And this was a bit tedious. It was good to have it in Git and have that kind of versioning control. But we want to act fast. And so now we can create probes within the browser. They are usually automatically attached to all the devices unless we create a filter and say, no, not on all devices. That osquery is just for devices that have that specific tag. And as we use JSON and YAML for the formatting of the probe, we know, okay, if you insert that into a browser, you can really mess it up. Formerly, we had the linting of your text editor, and this is powerful and says, alert, this wouldn't work, this is wrong JSON or wrong YAML. And so we now have basic linting in the browser that alerts you on, you want to alert on a Slack thing that is not existing, so that you can't save the probe unless you fix that problem. So if a probe is saved, we auto-reload the processor worker in the background, and from there on it's active. So, and for existing probes, because now the probes are stored in the Postgres database, we have an import script, and then they are like imported. So how to create a probe? Another short demo. I go to the probes menu, and I give the probe a name. So set it a name. Status is active by default. Then I set a description. That's inspect one password plist for compliance. And I have a pre-created osquery. I can copy that and test it out. And here's the schedule. We automatically detect it's an osquery, so you don't have to say that by creating the probe. And there you have the schedule and the details for one password, checking the plist. But we have no actions and further filtering, so it would be nice to have that as well. So we say, okay, update the probe. With the timing, 40 minutes. And I can update the filter. Just insert that save, and we still have no actions. And we insert the actions, and done. Now we can, for this probe, we can change the group membership in the JSS. We notify to Slack, and we add a tag to the machine. We've seen how that works. Some more examples. Automated file integrity monitoring, the broad schedule and in-depth. So we have one probe that listens for a process, let's say Dropbox, and we don't want that the people use Dropbox, but some do it. And if they do, we set a tag, and the tag automates another osquery, and the osquery activates file integrity monitoring, which is a bit more costly on the process, and just looks into specific paths. And if the condition Dropbox is running and something bad happens in the monitored paths, then we can alert on that and say, oh, a breach is to be reported. Short case study. As an MSP with Apfelwerk, we currently have around 933 devices. We have about 121 business units, and 3% are roughly the Linux servers, so not that many. And our main sources of inventory are Watchman, Munki, and JSS. And we roll out Munki more and more towards our clients that we manage. And in Germany, we can't, by default, switch on osquery and Santa, so we have to check with the client, is it okay to enter this more secure processes? But we can do that quite fastly if they say yes. So the server we use is a VM hosted in a German data center. It's a 4-core VM, 60 GB of RAM. Especially Kibana is very, very RAM hungry. And it's a Debian-based thing. And we use Elasticsearch, Kibana, Prometheus, and Grafana all on that machine. And we deploy with Docker Compose. And some surroundings is where we use Ansible. So this, I talked about the very, very defensive way of using Zentral. But yeah, let's look at the other side. It's about flexible response, and here's a scenario that we all know. This is another acronym, so I hope Alistair loves that. It's telling computers what to do. We know Tim needs some software for his work. He says Emily has to approve that, so he sends Emily an email, and Emily says, okay, he gets that software, it's a licensed software, and then Emily tells Daniel, hey, you have to install this software to Tim's computer, and in the end result, the software is installed to Tim's computer, and we know this process one way or the other, whatever tool set you use. We want to make monkeys dance for that when we are at Apfelwerk. So, and we think about, okay, how can we do that? And this is what we do with Monolith. It's quite new, it's closed source, and I show you how it works. Telling computers what to do, reload it. So this is a client with Munki. This is the software available in Munki. And this is the ticket. Can you please add our team tools, Slack, and HipChat to Tim's Mac? Here's the serial number. And this is Zendesk. And of course, we check shortly the serial number. Is it available? Do we know the machine, the device? Yes, it's tagged here with one tag. OK, what's next? OK, here's a new kind of probe. Add the team tools, and it's a Zentral command. This is a new kind of action we have, and we can give the command a name, add team tools, and we just as an action, we tag the device. We've seen it. Tagging is cool. And where we do that, we just write Zentral, $, then the command, add team tools, $, as a termination, device number or serial numbers, and then we have a termination, and we're very picky on the on the case sensitivity, and then we just close the ticket. That's it. It's much faster, and what happens in the background, we have a tag here that automatically was set by Zendesk, by this process, just closing the ticket and inserting the right information. And so let's run Munki. And Munki is retrieving results, manifests, catalogs, all that stuff. And we almost can expect what happens soon. We have software. This is nothing new, to be honest. Graham Gilbert did this with Sal Plus 3 years or 4 years ago. So we just need this in our business. So that's the reason why we are working on that. So that's the reason why it's currently closed source. And we need that workflow for our business. Technically, we create sub-manifests and attach a tag with a sub-manifest. And the catalog is synced with the webhook. So that's the Munki details. The Zendesk workflow you've seen is, of course, open source. It's available already in the source code. Yesterday, we did the last changes. And for the future of this workflow, because it could be interesting also to others than Apfelwerk, as Munki has so many different ways how to do it, I don't think that we have the resources to offer you all ways how to deal with Munki. And in the future, see Munki Web Admin 2 is the prime candidate to enable this workflow in a broader range, because Munki Web Admin is from Greg Nagel, and Greg is the author of Munki, so the father of Munki. So how to get started? We have the project on GitHub, and we also have a Twitter account we use here and there, and inform on some news and changes. So that's where the code lives. And we have recently created a 17-episode how to set up Zentral with osquery, Santa, and Munki, a tutorial series on YouTube. And this is really all the details that are missing from the presentation are in there. It's about 1 hour long, the total run. And you can really see how to use Docker Compose and integrate with Jamf, Watchman, and with Cell. And we even show ways to use Monkey Report PHP and Monkeybox on the notifications. If you use Monkey Report PHP and you get a notification, hey, this device has an issue, you want to see that in the dashboard, we provide the link and we build it automatically. And finally, on flying from Europe to Canada, I started to work on an ebook. It will be available for free we think that this could be complementing the videos quite well. Yeah, and this is about to be started. If you go to that link right now, you only will find a starting chapter on Santa, but yeah, you can just like start to attach and buy for free this ebook on LeanPub. So it's publishing in progress, and over the course of the next few weeks, we want to fill that up to an intro to Zentral and use Santa and osquery in combination with Zentral. The deployment, I have to finish, is mainly the quick start, as we show in the tutorials, is with Docker Compose. If you use that, you will see, oh, damn, it's 11 containers running this full Zentral thing. That could be scary for some people, but we use that at the moment in production. If you have Docker Compose installed, it's just like clone the code from Zentral, Docker Compose up, and you need to deal with some certificates. How to do that, hint in the tutorials. So it's all there. I hope you can't fail by following the tutorials. If you don't want to do that crazy Docker thing, it's just a Django app. You can deploy like any Django app. Currently, we don't have that fancy LDAP, SAML, whatever authentication. We just use htaccess. If you want to have that in the Django domain, it's all there. So, and I think there's many people who deal with Django. So contribution on that level is something that you could do, or just build it in for yourself. And with this, I say thank you, and probably some Q&A.
Questions?
That was amazing.
What?
That was amazing.
Thanks.
You. Very impressive. So for machines that are offline, is there some sort of queued mechanism?
Alistair, no, you just pretended that you know it, right? So what from our experience is that if Santa can't connect to the outside world, it will still run on the machine and store everything in the database. osquery does the same. The next moment, the connectivity is back, things will happen. Of course, if you download software, and then you hop onto a plane, you don't have internet, and the software you just downloaded is bad. And in the meantime, within Zentral, there's all the policies and probes to protect for that specific case. Yeah, we can't help you. But the next moment, you will connect back, all the events get shipped, and yeah, then you can start with that information, or even you have not started the binary yet. The next time you connect to the internet and connect back to Zentral, you receive the updates for osquery, the updates for Santa, and then hopefully you're well protected. An example is also covered in the tutorials, where we use the Key Ranger ransomware as an example, and show a way how to protect against this with osquery and with Santa, or to detect it with osquery and protect with Santa. It's just like in this tutorials, it's just every tutorial is about 3 to 5 minutes. So we have in the documentation on GitHub, we have a section where you can really cherry pick the topics that interest you, and yeah, hopefully you get more information out of that as well. More questions?
I think Alistair has something to say.
Scary.
So I had said that I was going to not BS and actually look up the correct answer, and it does relate directly to his question, so I'm sorry that I'm doing this. But the developer of Doorman actually helped me out with this. Events get written to RocksDB. They expire after a setting called events expiration, or after events max is reached. So you're going to have those things queued to disk for a while, stored, and the configs are local, so they're going to continuously be in effect. Just like Santa it writes its rules database to a SQLite DB that only root can read or write from or read anyway. But so yes, I wasn't actually BSing. Those things are actually real. And so if it can't get updates, it can't get updates. But it'll continue to enforce.
Thank you.
Fix.
Thank you.
Thank you.
Thank you, Henry. Everyone, thank you.